Please help me welcome Cathy Costello.
Good morning. So, why are snakes important to people? Why do we want to keep them around? Let's find out. So today we're going to go through some general ecological and economic benefits that most people are aware of. Then we're going to get into the exciting world of medical research into using snake venom as medicine for people. We're going to talk about how medicine's created. I'm going to talk about some specific venom activity types to help us further explain how it's possible to create medicine. And I'm going to use some specific Mississippi snakes as examples and some snakes around the world. And I'm going to throw in some general educational information about the majority of the snake examples I'm going to talk about. And specifically some information from a list I found online called The World's Deadliest Snakes. Most of the time, these lists that you find are only going to look at the toxicity of the venom, but this particular list I found looks at 6 different criteria, including the average size of an adult snake of that species, the venom yield, the toxicity of the venom, the length of the fangs, its typical defensive disposition, meaning how aggressive is it likely to be to a person, and the number of deaths per year from that species. So most people know that snakes really like to eat rodents. They eat other things too. But all living things obviously have a purpose in the ecosystem as created by God. But when there's an imbalance in the ecosystem, it can cause real problems. And an overabundance of rodents in the ecosystem can put human health and the economy at risk. There are 35 different diseases that rats and other rodents can pass from people, from the rodents to people. And a great example of how this can impact the ecosystem and the economy is a story that I read about a Florida dog worker, a worker in a Florida dog kennel. He started seeing snakes throughout the facility and decided those snakes had to go. So he went through, systematically killed every single snake that he found. Shortly thereafter, they experienced a plague of rats. It took them 2 years, hundreds of people hours, and thousands of dollars to gain control of the rats, to repair the structural damage done to their building, and to replace the hundreds of pounds of dog food that was either eaten or contaminated. So hopefully the people at that dog kennel have a new respect for snakes and the job that they provide. Now, snakes can also be a gardener's best friend. Small snakes likes to eat those insects that can tear up our gardens. These are just a few of the common non-venomous snakes you might possibly find on your property. There's a gray rat snake, a corn snake, and a ribbon snake, which looks a lot like a garter snake. Snakes can also control their own populations to some degree. Now, we know that king snakes like to eat other snakes. For some reason, that seems to be their preferred prey. They will feed on other animals too. These are 2 of our common ones, the scarlet king snake and the speckled king snake. And we have a speckled king snake up here today that you'll be able to look at closer at the end of my talk today. Now, we do have several other king snakes in Mississippi, and these 3 in particular are considered rare in Mississippi: the mole king snake, the black king snake, and the prairie king snake. Now, this is a picture. I apologize that it's somewhat blurry because I had to blow it up for you. It's a picture of a speckled king snake killing a copperhead. Now, there's been a study done that shows a direct correlation between the number of king snakes in an area and the number of copperheads in an area. The more king snakes you have, the fewer copperheads. The fewer king snakes, the more copperheads. Unfortunately, studies have shown that king snakes seem to be declining across the southeast. It's having impacts on the ecosystems that they're in, and because the copperhead is not being predated on as often, their populations are growing while our king snakes, for some reason, their populations continue to decline. So there's an example of how important it is to keep the predator in the equation to help balance the population of the prey animal. Now, getting into the exciting world of medical research into venom, first, I want to talk about hypodermic needles. Have you ever wondered how that invention came to be? Well, scientists at some point started looking at snake fangs, which are apparently just like hypodermic needles. They're hollow with a hole in the end. So I could stop right here and say that we all owe our lives probably to snakes, venomous snakes specifically, just for giving scientists the idea for this little invention. So how are drugs created from venom? First of all, venom as medicine for human illnesses is nothing new. It's been used since as early as 67 BC. However, I think it's safe to assume that back then those ancient physicians probably caused early death more often than they prolonged a patient's life, because they didn't have the technology we have today to separate out the toxins. They were probably injecting people directly with venom or just allowing the snake to bite the patient. So today, to create modern medicine, researchers go through a lengthy process that can take 6 to 25 years and millions of dollars. And it's important to note that it is not, the drugs are not based on the actual venom itself. It's rather based on a single toxin found within the venom. And I want to stress this because apparently there are people in the world that are allowing themselves to be purposely bitten by snakes in order to build up an immunity or to treat something, and I have to stress that that is not what I'm talking about today, and I consider that to be a very bad idea. So these toxins are actually used to learn where to aim the drug and as a blueprint for crafting the drug. So to understand further how this is possible, we need a basic understanding of how venom works. Venom is actually just modified saliva, very complex saliva. It's made up of different toxic proteins, peptides, and enzymes, each of which has a particular purpose, and then when it's put with another toxin, will have a completely different reaction. So it's extremely complex, and that is why it is such a rich resource for medicine. Each snake's venom can carry anywhere from 20 to 100 toxins. The venom is specific to each snake species. However, it can vary in composition within a single species. Between life stages, the composition can be different from a juvenile of the same species and an adult of the same species. It can also vary between regions and where the snake is found. And its diet can also impact the composition of its venom. Now, in general, when a snake uses its venom, it targets either blood circulation or communication between nerves and muscles of its prey in order to incapacitate and kill its prey. Now, as you'll see later in some of the examples, some snakes can actually do both, depending on what type of toxins they have in their venom. And each snake will do, the venom of each snake will do either one or any combination of these three actions by interrupting normal blood clotting, injuring muscle and numb nerves, or destroying cells of various types throughout the body. I'm going to go through and briefly talk about these 6 different types of toxins. The first one is hemotoxin, and we know that hemo refers to blood. So we know it's going to affect the circulatory system in some way. Depending on the type of toxin, it can destroy red blood cells, causing uncontrolled bleeding or excessive blood clotting. It can damage the vascular wall, meaning the actual blood vessel wall, and when that happens, that tends to cause the bleeding out of various orifices of the body. And in doing all this damage, it can lead to organ collapse and general tissue damage. Medical benefits that are coming out of hemotoxin are treatments for heart disease, stroke, blood disorders, and even potential cancer treatments. Snakes that have hemotoxins are rattlesnakes, copperheads, cottonmouths, and some cobras, as well as some other snakes. Now, neurotoxin, we know that neuro refers to nerves, so it's attacking your nervous system somehow. It works by interrupting communication between nerves and muscles. It destroys nerve tissue. And in one way or another, depending on the actual toxin, it's going to cause paralysis, which ultimately can result in respiratory failure and cardiac arrest. 3 specific neurotoxins that can be found in snakes. The first one is presynaptic neurotoxins. Those actually tend to damage the nerve cell, so recovery from a presynaptic neurotoxin is more difficult, especially if antivenom treatment has been delayed. The postsynaptic neurotoxins don't damage the actual cell, but they prevent the transmission of neurotransmitters, and so it's easier to recover from that with the antivenom. Dendrotoxins and fasciculins, I hope I'm pronouncing that correctly, is that right? Close enough. Those cause paralysis by causing muscle spasms and overwhelming the muscles. So some of the medical benefits are treatments for brain injuries, strokes, potential treatments for Parkinson's and Alzheimer's, epilepsy, multiple sclerosis, and even a new painkiller that we're going to talk about. Now, snakes that typically have it are cobras, sea snakes, kraits, coral snakes, mambas, and some rattlesnakes. Myotoxins. So myo refers to muscles. So one way or another, it's going to be attacking muscle tissue. It can cause systemic destruction of muscle tissue throughout your body. It's attacking those voluntary muscles, like the muscles in your arms and your legs. It does not usually attack the heart. And in doing that, it's going to cause just necrosis of the muscle tissue. It can affect the ability of the muscles to contract, so you won't be able to prey, hopefully not you, won't be able to run away. And it can cause secondary kidney failure in people. Snakes that have some myotoxins are fer-de-lance, sea snakes, Australian taipans, rattlesnakes, and coral snakes. Now, these other 3 toxins are very specific. Nephrotoxins specifically attack the kidneys, cardiotoxins specifically attack the heart, and necrotoxins specifically cause necrosis of tissue. Now, some of these other toxins we've talked about can also lead to necrosis, but there are some specific necrotoxins that typically cause necrosis at the site of the bite, but depending on how strong they are and how many different necrotoxins, it can spread throughout the body, causing more necrosis throughout the body. So, moving into some specific examples. Our first one is the copperhead, found in Mississippi and across much of the eastern U.S. It benefits the ecosystem by feeding on amphibians, lizards, other snakes, small mammals, birds, and the small ones especially like to eat insects. They are considered common. Interesting notes about them are that they're born alive. The young have a yellow tail when they're born that they use as a lure. They wiggle it to entice prey. And they're also responsible for about 85% of venomous bites in the southeastern U.S., probably partly because they're so well camouflaged, as you can see. They also tend to lie perfectly still. That's their defense, is to lay perfectly still in hopes that you don't see them. And the other snake that I have up here today is a copperhead, so you can come up and safely get a close look at it if you'd like to later. Now, specifically speaking about a subspecies of copperhead that is found in Mississippi called the southern copperhead. Now, I'm using this graph just as a visual aid to demonstrate the complexity of this snake's venom. I won't even try to explain it because my education's just not even there yet. I have a long ways to go with that. The toxins in this snake's venom are hemotoxins, some necrotoxins, and some myotoxins. Now, this is a perfect example of how scientists can go about creating medicine for people. The Researchers at the University of Southern California have been working with this venom, and I was able to contact their lead researcher, Dr. Frank Markland, who graciously provided me with a lot of information on their research so that I would be able to share it with you. So the first thing that they had to do was obviously acquire the venom. Then they broke it down into all of its many, many little complicated pieces, and they isolated a peptide called contortristatin, or CN for short, and they could see that it had potentially anti-tumor activity. So they needed to test it on human cancer cells to see what would happen. So they took these human cancer cells, and they were specifically looking at prostate, ovarian, and breast cancer. They put it into lab mice. So now we've got a lab mouse that has a human cancer tumor in its body. They put the CN into the mouse, and they discovered that yes, it does have some anti-tumor activity. What it does is it prevents the cancer cells from invading and adhering to healthy cells. It also keeps the tumor from developing new blood vessels, which essentially cuts off the blood supply and helps to starve and kill that tumor. So now that they know what CN does, they need more of it. There's not enough copperhead venom in all the world to provide enough CN for them to have enough to continue their research. So they had to find a way to synthesize it and mass produce it. So one of those researchers at the university took the CN and found a way to put it into bacteria and have that bacteria grow a synthesized version of it, which they call vicrostatin, or VN. So now that they've got the synthetic version of it, and it's cheaper and easier to make, and obviously safer, so now they need to test it and find out, does it do the same thing as CN? So again, they took the human cancer cells, they put it into the mouse, they put the VN into the mouse, and discovered that, yes, it does do the same as its parent CN, but even better. It is more effective at fighting the prostate, ovarian, and breast cancer. And as an added benefit, it has a minimal to no toxicity to the host. So unlike some of our current cancer treatments like chemo and radiation that basically poisons the whole body in order to treat the cancer, this can be specifically targeted to the tumor without damaging the rest of the person's body. The current status of this research is that they're waiting for funding. And once they receive funding, they have to hire an outside contract research organization that will demonstrate that a commercial entity can produce and purify this synthetic peptide that they've created, and that it retains full biological activity equivalent to the lab scale peptide that they created at the university. Once they do that and get that proven, then they have to hire another research organization that will demonstrate lack of toxicity in studies that are required by the FDA. Excuse me. And then once they get that study completed, they will apply to the FDA for an investigational new drug and design clinical trials to demonstrate activity in patients with human cancer. And yes, I'm reading this exact note from Dr. Markland to make sure I didn't mess that up. Also to note that CN also shows strong promise for development as a treatment for herpes. Our second Mississippi example is our little southeastern pygmy rattlesnake. It feeds on lizards, frogs, small mammals, insects, including centipedes. It can be 14 to 22 inches long, hence the name pygmy. It's little and cute. It is protected in some states. However, in Mississippi, I don't think it's protected. I don't think it's considered rare. But in some states, it is. Interesting notes are that they are also born alive, and the young are also born with that yellow tail that they can use as a lure. Toxins in the pygmies venom are hemotoxins and potentially some other necrotoxins. Scientists have isolated a chemical called eptifibatide in its venom, which has led to the creation of a blood thinner called integralin that is being used to treat heart disease, high blood pressure, and can even stop oncoming heart attacks in its tracks by breaking down the blood clots. It was approved by the FDA in 1990s. So our very own Mississippi native snake has been saving lives since the 1990s. Our second rattlesnake, and I want to stop and note that Mississippi has over 50 species of snake. Only 6 are venomous. I'm going to specifically talk about 4, and 3 of them are rattlesnakes. So our second rattlesnake is the eastern diamondback, found across the lower coastal plain of the southeast. And you can see that it's mostly found along the coastal counties and throughout Florida. It feeds on small mammals, particularly rabbits. It can be 3.5 to 5.5 feet long with a record of 7 feet, which was probably in captivity. It is a species of concern across the majority of its range, actually probably all of its range. It has experienced sharp declines in population in the last decade with no evidence of recovery. They are born alive, and one of the reasons why they're going to be slow to recover their population numbers is that they mature very slowly, and then the females only reproduce 2 to 3 years, every 2 to 3 years between litters. Toxins in its venom are hemotoxins, potentially some other cytotoxins, and depending on where it's found, varying amounts of neurotoxins and myotoxins. Now this is the largest venomous snake in the U.S. and the largest rattlesnake in the world. It has huge venom glands, meaning that it's going to yield quite a bit of venom in a bite, and it has relatively long fangs, which on that list that I mentioned, the world's deadliest snakes, it received a score of 18 out of a potential 30. Each of those criteria I mentioned are scored anywhere from 1 to 5. And then adding those 6 up, it could have a potential of 30, and this one was given an 18. So we know that one of our snakes is on the deadliest list. Now scientists have isolated a toxin in its venom that they call Crotalus adamantius toxin 2, which is just named after the scientific name of the snake. It is an antibacterial protein that they've tested on skin wounds. Right now it's just been in mice in the lab. They tested on several different bacteria and skin wounds and found it to be far more effective than current antibacterial treatments that we have now. It was not toxic to the lab mice at all. They also tried it on human lung and skin cells and found it to not be toxic on those cells as well. Could this be the solution to the antibiotic-resistant bacteria that we're hearing about in the news that is killing so many people? Researchers are hoping so, but there's a long way to go into this research. Our third rattlesnake in Mississippi is the timber rattlesnake. It's found across the majority of the eastern U.S. It feeds on rodents, squirrels, rabbits, and sometimes birds. It can be 3 to 5 feet long with a record of 6 feet 2.5 inches, again probably in captivity. Its population is also declining like the eastern diamondback, and it is protected in some of the northern states. It also is born alive. It takes them 5 years to mature, and then again 2 to 3 years between litters, so any population recovery is going to be slow again in this species. Its venom contains hemotoxins and myotoxins. It can have an exceptionally bad bite, but they're not aggressive. They would much rather you just walk away and leave them alone. They don't want to bite you. So that gave them a score of 11 out of 30 on the deadliest list. Researchers in India have created a homeopathic medicine that they say can stop the multiplication of the human immunodeficiency virus, which is the virus that we know causes AIDS. Now that medicine is not here in our country, but hopefully that research can lead to an FDA-approved treatment in our country one day. It certainly can give us hope. And we know that Lyme disease is caused by a particular type of tick, and ticks are typically found on mammals, although they can be found on some other animals. Human cases of Lyme disease are on the rise, while predator populations are declining. By keeping our predators alive and healthy, we can prevent diseases like Lyme disease and some others. Now, the article that I read about this subject was specifically promoting protection of the timber rattlesnake, but I think it goes to all predators, not just snakes, but other predators as well, that are very important to the ecosystem and to human health. Okay, that was our 4 Mississippi examples, so we're going to move into the venomous snakes around the world. The derived pit viper is one of the snakes that's referred to as a fer-de-lance, and if you've heard about deadly snakes around the world, you've probably heard of the fer-de-lance. Well, it turns out most of the snakes in the Bothrops genus are referred to as a fer-de-lance, and this is just one of them. And it's a perfect example of, if you look at these 2 graphs, the bottom graph is the composition of venom in a newborn derived, and the top one is the composition of an adult. And you can see that they're quite different. The toxins in this snake are hemotoxins, necrotoxins, and potentially some myotoxins. This snake's venom led to the creation of ACE inhibitors. The first one was captopril, approved in 1981 by the FDA. And the second one was enalapril, approved shortly after. It's used to treat high blood pressure and congestive heart failure. Before the creation of ACE inhibitors, there was another type of treatment, but it had terrible side effects. But thanks to the invention of ACE inhibitors, high blood pressure is now a treatable and not necessarily a fatal disease any longer. It reduces the risk of heart attack, stroke, kidney disease, and diabetes. And for someone who's already taking an ACE inhibitor that has a heart attack or a stroke, it increases the survival rate. It has few side effects, as I mentioned, compared to the previous high blood pressure treatment. 2 more fer-de-lance snakes are the common lancehead and the Brazilian lancehead, also found in South America. The common lancehead toxins are hemotoxins, myotoxins, nephrotoxins potentially, and potentially some other necrotoxins. They are large, very defensive snakes responsible for a lot of bites in South America, earning it a score of 21 out of 30. And while this is specific to the common lancehead, we can assume that the Brazilian lancehead is going to be similar, and you'll see why. There's a chemical called batroxybin that was isolated in the venom of these 2 snakes, used to create something called defibrase, which is used to treat a specific type of stroke and chest pain caused by an inadequate supply of oxygen to the heart, and a condition called sudden deafness, where someone can just suddenly wake up one morning, be completely deaf in one ear and in severe pain with horrible vertigo. Apparently, this defibrase can help to treat that condition. Now, batroxybin was also used to create these 3 items. The first one being a gel that can be used to help chronic lesions kill and speed bone regeneration. It's sometimes used in oral surgery. The second one is used to glue tissue together during surgery. And the third, the hemocoagulase, is used to prevent and treat hemorrhage during surgery. So these 2 very deadly snakes are helping to save lives in a lot of different areas. Researchers at Rice University have created a nanofiber hydrogel infused with batroxybin that halts excessive bleeding by starting clotting within 6 seconds. If you can imagine, if someone's got a terrible injury, they're bleeding out, starting that clotting process so quickly can save lives. It also is important to note that it does not interfere with heparin, which is a particular type of blood thinner that some people need. Potential applications for it are treatments for small cuts and wounds that could be really important on, say, an ambulance when someone's in an accident, and also as a surgical gel to stop internal bleeding. It is not yet in clinical trials, it's still in research. The fourth fertilance is the Barbara amarilla, found in Central and South America. Now these two graphs are just two different ways, two different methods of breaking down the composition of the venom. They look at it one way, they see certain things. They look at it another and they see totally different. Well, not totally different, but they see other things that they couldn't see in the first example. So some of its toxins are hemotoxins and myotoxins. Again, it's large and aggressive, has lots of toxin venom, and it's able to strike more than half its body length, which is unusual. Most snakes can strike somewhere around their body, half their body length or less. These particular snakes, not just this one, but I think all of the subspecies of Bothrops can do that, giving this particular one a score of 23 out of 30. Now, researchers and doctors are in constant debate over the cause of Alzheimer's, but some of them agree on some of the mechanism that somehow lead to it, and that's an enzyme that the body naturally creates that for some reason at some point in a person's life that enzyme will start to decrease, and then a plaque will start to build up in the brain. That enzyme was keeping that plaque from being able to build up. So they isolated a myotoxic peptide in this snake's venom that stimulates two of those enzymes that can fight or help to prevent or slow down the plaque buildup in the brain. It is still in the research phase, but again, we have hope that there will one day be a great treatment for a horrible, horrible disease. The saw-scaled viper is found in Africa, I believe. Its toxins are hemotoxins, potentially some necrotoxins, and potentially some nephrotoxins. It kills more people in Africa, yes, it's Africa, than all other African venomous snakes combined. Humans, for some reason, are extremely susceptible to its venom, earning it a score of 19 out of 30. Researchers at Merck Research Labs and Temple University isolated a protein called echistatin that is an anticoagulant. It is not toxic. After 10 years of studying it, they created Aggrastat, which is now used to treat heart attack patients, and it was approved in 1998. An extremely deadly snake that is killing more people than all the other African venomous snakes combined is saving lives in our country. The Malayan pit viper, found in Asia, Southeast Asia, has hemotoxins and potentially some necrotoxins. Its venom is said to kill and even dissolve tissue, including bone. Scientists have created a medicine called Vipernex. It is, again, an anticoagulant. It's used to treat stroke victims. And in 42% of the patients that they tested it on, they recovered within 3 hours from their stroke. It is not FDA approved yet, it's in clinical trials. The eastern green mamba, found in Africa, has the dendrotoxins and fasciculins, which we talked about earlier, is one of the neurotoxins that causes horrible muscle spasms. Researchers at the Mayo Clinic have taken a peptide from its venom and fused it with a peptide found in the lining of human blood vessels and created something called senduritide, which can be used to treat congestive cardiac failure by lowering blood pressure and reducing fibrosis. It also shields the kidneys from an overload of salt and water that can be detrimental to kidneys and it is currently in clinical trials by the company Capricorn Therapeutics. Another mechanism that seems to lead to Alzheimer's is a decrease in the neurotransmitter acetylcholine. Scientists have isolated a toxin in the green mamba's venom that they call fasciculin 2. It can increase acetylcholine. It's still in the research phase, but again, a potential treatment, if not a cure, to a detrimental human illness is hopeful. Now the black mamba, I'm sure you've heard of the black mamba if you've heard of deadly snakes around the world. It also has the dendrotoxins and fasciculins. It is very large, alert, and extremely aggressive when threatened, and it's one of Africa's most feared snakes with good reason, earning it a score of 20 out of 30. And to note, of the 32 snakes on this list I'm talking about, there were only, I think, 3 that received a score of 23, and that was the highest score. Scientists have isolated mumbalgens, a substance found in the venom of the black mamba, which has been shown to be as strong as morphine. It has 0 side effects. Unlike morphine and some other extremely strong painkillers that have suppressive effects on the body and addiction and all that, this one has 0 side effects, and the company TheraAlpha is working to develop these pain-killing compounds. Now the king cobra, I think, is one of the most fascinating snakes in the world. They're found in Africa. They can reach a length of 18 feet. They're the largest venomous snake in the world. Unfortunately, their populations are declining, and it is considered a vulnerable species. The most interesting thing about it is that it builds a nest, like a bird. It is the only snake known to build a nest. The female will build her nest, she will lay eggs in it, and she will actually protect that nest until just before time for those babies to hatch. So she leaves before they hatch, she never actually meets her babies. Again, a visual aid of the extreme complexity of this snake's venom. It contains hemotoxins, postsynaptic neurotoxins, cardiotoxins, myotoxins, and potentially some other types of necrotoxins. It is highly intelligent. Some people say one bite can kill an elephant because it releases so much venom. I do not know if this has been observed in nature. But it has earned it a score of 21 out of 30. Its venom is so complex, it's been studied for over 50 years, and scientists are still finding new toxins in its venom. Currently at the University of Singapore, they isolated a protein called Hattie toxin. It's one of the most recent discoveries. And it also might be a treatment for chronic pain. It is 20 to 200 times more effective than morphine. And once again, 0 side effects. The medicine they've created is called analgesic, and it is currently in clinical trials. The venom of the king cobra, the black mamba, and various king snakes are also being researched into potential treatments for Parkinson's and Alzheimer's. Unfortunately, I don't have any specifics on these 3 yet. I've just found a note in a news article. So, there are still around 20 million toxins in nature that have yet to be explored. And that's not just snake venom toxins, it's toxins in all the other venomous creatures. And as we've seen, venom could hold the cure to many serious human ailments. Unfortunately, snake populations seem to be declining around the world. Now, when we're looking at conservation efforts, it's important to not just consider biodiversity, but molecular biodiversity. For example, if we save all the eastern diamondbacks in southern Florida, we've done great at preventing it from becoming an extinct species. But if we lose them in all other areas of their range, we've lost the pharmacological benefits of a whole lot of other compounds.